Hello my dear students, welcome to our channel MST Physics where physics gets charged. The last video we discussed the concept of distance and displacement and some numericals. Now today we will discuss again applications on this distance and displacement. Okay, so in this we are taking one application is that the particle is moves along the circumference of a circle of radius r and it started its motion from point P and reaches to the point Q, so that this arc PQ makes an angle theta at a center. So then what are the distance and displacement, this course of motion here? So irrespective of the path, whether it is a rectilinear or curvilinear, the distance traveled by the body is nothing but the length of the path traveled by the body. So here the distance is used length of the arc PQ is used the distance travel, and we know from basics length of the arc is equals to angle into radius, means we can write r theta is the distance covered angle into radius, and that angle should be in the radians only, right? So now when I am coming to the displacement, to find the displacement of the body which is moving from point P to Q along the arc. So always the straight line joining from initial point to final point is used the displacement. So based on this, whenever you are joining from point P to point Q, that length of the curved PQ is used the displacement here. Length of curved PQ is used the displacement. So to find this, I would like to draw one normal from point O onto this PQ, so that it is the angle bisector, and here the angle should be of theta by 2, and this PS is equals to SQ. So to find this, I am considered triangle OSP. So in this OSP, if you are trying to write sine theta by 2, so sine theta by 2 is the opposite by hypotenuse, so that opposite side is the SP and hypotenuse is the OP, so which gives here SP by R. Therefore SP is equals to R sine theta by 2. And again, as we need PQ, so curved PQ can be written as is the bisector on this PS, so PQ, so we can write PQ is equals to 2 times of SP, so which gives here 2r sine theta by 2, which means the displacement of the body, we can write the displacement is equals to 2r sine theta by 2. Okay, this is the way we can find the distance covered and displacement covered, and don't cut this 2 and 2 place. Here it is inside the sine function is a multiplier. Some of the students do like that, don't do like that. Okay, so now here this, if it complete half rotation, when it complete half rotation, what is the angle made by it? So the angle made by it at the center, theta is equals to 180 degrees, means pi radian. So then the distance will become what? Angle into radius, pi r is the distance. And coming to the displacement, so this displacement is equals to, so here we have 2r sine theta by 2 is nothing but pi by 2. Yes, it is a 2r. So see the diagram also, if it is here as it moves along this, when it is a 180 degrees, means it is coming a diametrically opposite point. So the displacement is nothing but diameter is a 2r from geometry, and from this basic formula will get same. Like that you can find for 1/4 or 3/4 or making any angle like 120 degrees or 60 degrees, 30, for any angle you can find by using these two formulas of displacement is a 2r sin theta by 2 and distance is a r theta. Otherwise the same displacement can also be found by using vector notation. See here in this circular diagram only, see this is the initial point of the particle from the origin, let it is a r, and it moves along the circumference of the circle and reaches to the point Q, so that line joining these two is used again radius only. Okay, so now as it moves in the anti-clockwise direction, the initial point joining the line from initial point to final point is gives displacement. Means here according to vector addition, can I write a OP bar plus PQ bar is equals to OQ bar? Why? Because as we have discussed, while adding the two vectors geometrically, join the initial point of second vector to the final point of first vector. So initial point of PQ is this, final point of OP is here. Yes, we are joined. Okay, OP is joined with the Q, and to get the resultant of these two, joining the initial point of OP is this to the final point of PQ is this. So we can write OP bar plus PQ bar is equals to OQ bar. So say for our convenience, it is supposed to be R1 and R2. Let actually radius are same, supposed to be R1, R2. So that can write OP bar as R1 bar, PQ bar is a D bar which is unknown for us, OQ bar is a R2 bar. By this we can write D bar is equals to R1 bar minus R2 bar. So when we are taking the difference of the two vectors and they are at certain angular theta to each other, then the resultant is, by using parallelogram law of vector, under root of R1 square plus R2 square minus 2R1 R2 cos theta, which we are learning in the parallelogram law of vector, isn't it? But here R1 is equals to R2. R1 is equal to R2 or not? Okay, why? Because if you are writing R minus R, it is not 0, please. It is what? 0 when there is an angle between them is 0. But here the angle between them is theta, so it is not possible to write this R minus R bar is equal to 0. That's why, to avoid the confusion, at first I am taking R1, R2, and then now the actual thing I am taking R1 is equal to R2, that is equals to R. Again, from special case of vectors, parallelogram law of vectors, we know when two vectors of same magnitude and of the angle between them is a theta, then the resultant of the two is 2r sin theta by 2. This already we are derived in the vectors. You may check from there, right? So D bar is what? A displacement only. So displacement D is equals to, we will get a 2r sin theta by 2. Again I am getting same by using the vector concept, and this is what I am derived by geometrical knowledge. Both will lead to the same result only. This is the way we can find distance and displacement in the case of particle moves along the circular path. Okay. So now we are coming to one problem. What is the displacement of a point of a wheel P initially in contact with the ground? Let this is the wheel whose radius is supposed to be R, and the one point of a wheel is contact with the ground initially. When the wheel rolls forward for half a revolution, what means let this is the wheel supposed to be, this cap is a point which is in contact with the surface. So when I am rolls here, after half revolution this will be coming to top. It is the first, this is the first initial in contact with the ground. On revolving here it comes top. When it comes top, so that this point P will coming to here is supposed to be P dash. Okay, when it is coming to P dash, so now we have to find the displacement of this point which is in contact with the ground at first. Okay, so further, so when it rolls half rotation along the horizontal distance, means from here to here, let this is the point Q, will cover half the circumference. When it is a half the circumference, let this is the distance x. This distance x can be written as half the circumference is a pi r, and the displacement can be obtained by joining the line from initial point to final point. So this is what P dash is the displacement. And again, when you are joining the point from P dash to Q with the center, this is what the vertical displacement y, and that y is gives the diameter of this circle or this roller or wheel. Okay, so distance covered at first, the distance covered, otherwise x distance along x axis. Distance covered along x axis, it is the x axis. So it is the half the circumference definitely. So x is equal to half the circumference is what? Pi r. And vertical distance covered, vertical distance, so this is supposed to be y. This y is equals to, we can write a P dash into Q, which can be written as 2r. But now our intention is to find the displacement. Now the displacement of the wheel can be obtained. Displacement of a wheel point P. So this is equals to P dash. This P dash can be obtained here. The P dash Q is a right angle triangle. So that in this we can write a P dash is equals to square root of PQ square plus P dash Q square. Otherwise we can write a displacement is equals to under root of x square plus y square. I am supposing this is the x and here is the y, and x I got a under root of pi square r square plus y square is a 2r whole square, means which is a 4r square. When taking r square common outside the root, it is a r under root of pi square plus 4 is the displacement, okay. And if they are asking what should be the direction of the displacement, to know the direction here, the angle made by this displacement with the x-axis is gives the direction. So to find this, again here P dash Q is the right angle triangle. For this tan theta is equals to opposite side by adjacent side. So to know that its direction, can I write tan theta is equals to P dash Q upon PQ, which gives y by x. So therefore tan theta is equals to y is of 2r, and the x is of pi r. So r get cancelled, 2 by pi. Therefore theta, which gives the direction of the displacement, which can be obtained by tan inverse of 2 by pi. This is the way we can find the direction of the displacement as well as the magnitude of the displacement by using this concept. And again here in this problem it is said to be rolls forward half a revolution, but in furtherly they may be asked to find it may be of 1/4 revolution or 3/4 revolution. 1/4 or 3/4 revolution. So again coming to the same point, when it initially this is what in contact with the ground, when it is said to be 1/4 revolution, it is coming to horizontal. When it is coming to horizontal, means the point should be here. Understood? This is what initial point. It is 1/4 revolution, half revolution and 3/4 revolution. For 3/4 revolution, the point will be here. Again same, when it is 1/4 revolution, I am coming to do for this, for 1/4 revolution. So here we need to join in this diagram I am showing you. So this is the line we are joining. So here it is the vertical line. So in this case the x will become, so for 1/4 revolution, x is 1/4 of circumference of the circle. 1/4 of circumference of circle means 2 pi r by 4 is a pi r by 2 is the horizontal distance covered of this, and the vertical distance covered y is equals to, so when I am coming to here, definitely it is along the origin only. One of this is a radius r, this should also be radius r, so that y is equals to r. So remaining is the same. Again there is a right angle triangle is formed. By using this you are finding the displacement, and again by using tan theta you can able to get the direction. And similarly when I am coming to 3/4 revolution, can you guess that the x and y for a 3/4 revolution, when it is coming to here, it definitely covers 3/4 of the circumference of the circle. 3/4 of the circumference of the circle is, so revolution x is equals to 2 pi r into 3 by 4, which gives 3 pi r by 2 is the value of x. And for y value, again when it is coming to here, this definitely of radius of the circle only. After getting this x and y value, it's a very simple, by using mathematical steps of under root of x square plus y square, you will get the displacement. And again by here also, when you are joining this line, you will get a right angle triangle. Again by using that tan theta is equal to y by x, you will get the direction. These are the way they are asking the different models of the questions based on this wheel in rolls. Okay students, thank you for watching. If you are like my videos, do like, share, comment and subscribe my channel to get more videos.